Hey guys, welcome to Complex Numbers Part 4, What is the square root of a complex number? And you're currently in the fourth part of this complex numbers series, so if you want to go start from Part 1, feel free to do so, but if you kind of have a grasp of complex numbers already, such as what is an imaginary part of the complex number, what's a real part of the complex number, then you could just skip those videos and just stay on this video and see what is the square root of a complex number. So let's get started. Let's move on to the actual proof. How are we going to prove what is the square root of a complex number? So let square root a plus ib equals x plus iy, where x and y are real numbers. So this is just a general assumption that we're going to make. And from this assumption, let us take this. I'm just going to rewrite this as it is. So a plus ib equals x plus iy. Squaring both sides to get rid of the square root, you get a plus ib equals x plus iy squared. Simplifying the right-hand side, you get x squared minus y squared plus 2ixy. How I got minus y squared, it's because over here you get I squared y squared. We know that I squared is minus 1. Minus 1 times y squared is x minus y squared. Okay, now we see somewhat of a relationship. We see there's an imaginary part here and an imaginary part here. And this is the real part and this is the real part. Let's set the real parts and the imaginary parts equal to each other. So let me write it in a different color. Setting the imaginary, I'm just going to write IM for imaginary parts equal to each other, and that is the same for the real parts. So I'm abbreviating real to RE. So we know A is the real part and x squared minus y squared is the real part. So A equals x squared minus y squared. We know IB is the imaginary part and 2ixy is the imaginary part. So that's b equals 2xy. Because we know the I is common, so that's basically saying b is equal to 2xy. Now moving on to the next step, we know that x squared plus y squared squared equals x squared minus y squared squared plus 4x squared y squared. It's just a general formula. How do you know both of them are equal to each other? Well, you just expand it and eventually the right hand side will be equal to the left hand side. But why did I put it in this form per se? Well, that's because from up here we know what x squared minus y squared is equal to. So we can substitute in here. We also know 2xy. And here this is basically just 2xy squared. So this, we could rewrite this as, well, I'm just writing it as the same. And this is 2xy squared. The left hand side is just going to say the same, and we're going to replace whatever we know on the right hand side. So x squared minus y squared from here is a, so a squared. And 2xy squared is going to be b squared. So the left hand side is x squared plus y squared squared. And now taking the square root of both sides, we get x squared plus y squared equals square root of a squared plus b squared, which is going to be an important equation. Alright, so the next step is to solve 1, 2, and 3. And by solve, I mean find x squared and y squared. So here, we just want to find, aka, find x squared and y squared. So how do we do that? Well, we have all the key components. We have equation 1, 2, and 3. From 3, we know that x squared equals square root a squared plus b squared minus y squared. I just subtracted y squared from both sides. From equation 1, we see that y squared is equal to x squared minus a. From equation 1, y squared equals x squared minus a. Substituting this y squared into here, so we get x squared equals square root a squared plus, no idea what I wrote, a squared plus b squared minus x squared plus a. Taking the x squared to the other side, you get 2x squared equals square root a squared plus b squared plus a. And therefore, dividing 2 by both sides, you get x squared equals 1 over 2 square root a squared plus b squared plus a. Alright, so we got y squared and x squared. I just saw y squared like I did before. So now we can find x and y. So you just square root both sides. X equals square root of 1/2 square root a squared plus b squared plus a. I'm going to do the same exact thing for y. And the x is going to be plus minus because we're taking the square root. So y, same thing, plus minus square root 1/2 times square root of a squared plus b squared minus a. And then square root all over that. And these are also important equations, so I'm just going to highlight these. Alright, so we're coming to an end of our proof, basically, but there are going to be practice problems towards the end, so stay tuned for that. But what do we do now? Well, we have the value of x and we have the value of y. Going back up to b, we know that b is the imaginary part, right? Over here we see that b is connected to I, so b is like the imaginary part. So b equals to xy. So if b is positive, we know that xy has to be the same symbol, right? Because if x, y are both negative, that makes a positive. If x and y are both positive, that also makes a positive. So when b is 0, both x and y have to have the same symbol. The same symbol, oh my gosh, the same sign. I don't know what's wrong. To have the same sign. And that sign could either be negative or positive. But they both have to be negative or they both have to be positive. So this is actually the first case. So we're kind of splitting it up into 2 cases. So let's solve this first. If b is greater than 0, both x and y have to have the same sign. So we have x and we have y. Basically what we're saying square root of a plus ib will have to have the same sign. So therefore they're either both positive or they're both negative. So if we take the plus minus outside, we have square root 1/2 square root a squared plus b squared plus a plus I, because once again, y all the way up here is the imaginary part over here. Y is the imaginary part. So that's why I'm including an I square root, oh my god, so many square roots. And I made a mistake over here. The square root does not go over the a, it's just a squared plus b squared. So back to this y, we have I square root 1/2 a squared plus b squared square root plus a. Oh, minus a. Minus a, because we have a minus a over here. Alright, so you guys may be a little confused. How are they both the same sign? Well, we know if both of them are positive, which they are right now, if there's a positive outside, let's say there's no negative, then we have positive times positive, positive times positive, both x and y are positive. If we have a negative, we have negative times this, which is negative, negative times this, which is negative. So therefore, either way, x and y will be the same sign, which satisfies the first case. Now, on to the second case. So the second case, you can probably already guess, when b is less than 0, both x and y have to be different signs. Have to be different sorry for my handwriting. Different signs. Because negative times positive is negative, positive times negative is negative, and that negative represents b is less than 0. So once again, we're going to do the same thing, a plus ib. And what I'm doing over here, I'm just replacing x and y in, where'd it go? In here. That's all I'm doing. So going all the way back down, we have square root of a plus ib. Now, how do we make them so they have different symbols? Here, it was pretty easy, right? Because now, if we expand the plus or the minus, whatever it is outside these parentheses, it's always, x and y are always going to be the same sign. And here, they have to be different signs. Well, it's not too tricky. You have the plus minus 1/2 square root, oh, there's a parentheses, square root a squared plus b squared plus a. And then once again, we have the I, square root 1/2, another square root, a squared plus b squared minus a, parentheses. Now, if we have a plus over here, that's the same thing as this one. Both x and y are going to have the same symbol, but we don't want that. We're taking a separate case where x and y have to be different signs. So if we put a negative, for example, here it's a positive, here it's a negative. You multiply positive by positive, you get positive. Multiply positive by negative, you get negative. And you could do the same thing for that negative sign. So here is the main formula to find the square root of any complex number. And yes, it's a lot to take in, but after we've proved it, I hope you got a pretty good understanding of how we got this. So now over here, you see that there's no a, b, x, or y, right? That's because we want to make sure the formula is in terms like real part of z, imaginary part of z, because that's all a, b, x, and y are, right? They're either imaginary part of z or a real part of z. So what we did, we took this square root a squared plus b squared. We know square root a squared plus b squared is the modulus of z, so that's why there's a modulus of z right there. Furthermore, we know a is the real part of z from above. Let me show you. From above, we know a is the real part of z. A, right over there. And I think that's all you need to know to understand what is all of this, basically, as long as you know how to find modulus, which was discussed in part 3, I believe, of this complex number series. As long as you know what a modulus is, what a real number is, what an imaginary part is, I think you are good to go. Now for some practice problems. Alright, so our practice problem is find the square root of 7 minus 24i. And all you need to do is look at the formula and just replace the corresponding values. But be careful because you want to know if the imaginary part is greater than 0 or less than 0. So pause the video and give this problem a go. Alright, so hopefully you gave that problem a go. Once again, here is the formula to find the square root of a complex number. So let's get right into it. So we know that a is equal to, not minus 7, is equal to 7, and b is equal to minus 24. From the get-go, I see that b is negative, so we know that we're going to use the second case here because the imaginary part of z is negative. And from there, we could simply just substitute. So we have this plus minus. I should probably erase that. That looks a little confusing. Plus minus, and then we have these big curly braces. Square root absolute value of z plus real part of z over 2. So square root of the absolute value of z. Absolute value of this, let's say this is z, is square root of 49 plus 24 squared, which is 25. So now we have the absolute value of z. Let's replace that. Whoops. 25. And then up here we have plus the real part of z. Real part of z is a. A is 7 over 2. Minus, remember we have the minus I. And once again, same exact thing, except with a few differences. Same thing, absolute value of z. We found that out to be 25. Minus the real part of z. Minus the real part of z? Yeah, real part of z is 7 over 2. Curly brackets closed. Solving this, you are going to get square root z equals plus minus 25 plus 7 is going to be 32. Minus I. 25 minus 7 is going to be 18. Simplifying the square roots, you get plus minus square root 16 minus I square root 9. Square root z equals plus minus 4 minus 3i. And that is your answer. Alright, so hopefully you got a gist of that, how to take the square root of a complex number. All you really need to do is remember this formula. As long as you know how this formula works, I think you're all set to go for finding square roots of complex numbers. And don't forget to always look Oh, whoops. Don't forget to always look if the imaginary part is either positive or negative. Here it's positive, here it's negative, because that is really going to affect your answer. And also don't forget the plus minus sign. And yeah, thank you for watching, and I'll see you guys next time.